Hello, this is Mr. Collier, and today we're looking at the angles between a line and a plane, and then we're going to look at angles between two planes. Okay, so if we got a line here, this is the line we're talking about right here, and here is a plane, and the angle between the line and the plane is theta. Okay, but if we look at the normal to the plane, it makes an angle to the line here, right? And these two angles add up to 90 degrees. So if you want to get the angle theta, you take 90 minus phi. Alright, so then we have, this is straight out of the formula booklet, we've got an extra absolute value sign here to make it positive, and that'll always give you the acute angle. Okay, so if you want to find the angle between two vectors, you can use this formula. So we're getting the angle between the normal and the line, and then we do 90 minus that angle, and we'll get the angle between the line and the plane. So let's do an example. Find the acute angle between this plane and this line. So the normal vector here is 1, 2, negative 1. And here's the direction vector, so I'll call that u. And we've got cosine theta equals n dot u over the magnitude of n times the magnitude of u. And if we do the absolute value, we'll get a positive number. Oh, it's only brackets here. Okay, so we need to do n dot u and get the magnitude of both of them. Let's do all that over on the side here. So n dot u is 1, 2, negative 1 dot 1, negative 1, 2. And that gives us 1 minus 2 minus 2, which gives you negative 3. And next we are going to do the magnitude of n, which is root 1 squared plus 2 squared plus 1 squared, which equals root 6. The magnitude of u is root 1 squared plus 1 squared plus 2 squared, which also equals root 6. So then we just use our formula. Cosine theta equals negative 3 over 6 was actually an absolute value of that. So it actually gives us half. And we can do this non-calculator. Cosine theta equals a half. So we're talking about this right triangle, 1, 2, root 3. So cosine theta equals a half would be this angle, which is pi thirds. So we have theta equals pi thirds, or often we use degrees for angles between planes, so we could say it equals 30 degrees, I guess would be a better answer. Okay, next we're going to look at the angle between two planes. Now if you got two planes and you look at their normals and you get the acute angle between those two normals, you can see from this diagram it's going to be exactly the same. If you look carefully, it's quadrilateral. You got two 90-degree angles, so the other two angles add up to 180. So this angle here is 180 minus theta. So this angle here also has to be theta. So in this case, these two angles are exactly the same. And to get the angle between two planes, we can simply get the angle between the two normals. Perhaps I should have vectors here. Okay, so that's it. Let's do an example. So we got the normals. Call it normal 1 is 1, 1, negative 1, and normal 2 is 2, negative 1, 3. So we can use the formula cosine theta equals n1 dot n2 over the magnitudes. Okay, and if you want to get the acute angle, I guess you can do the absolute value of it as well. So n1 dot n2 equals 1, 1, negative 1 dot 2, negative 1, 3, which equals 2 minus 1 minus 3, which equals negative 2. And the magnitude of n1 is root 1 squared plus 1 squared plus 1 squared, which equals root 3. Magnitude of n2 equals root 2 squared plus 1 squared plus 3 squared, which equals root 14. Now we already used the formula, so cosine theta equals, well, it's absolute value, so I'm going to use a positive 2 over root 3 root 14. So theta equals arc cosine of that quantity. Okay, then we're going to do that on the calculator. So inverse or arc cosine, then I go to alpha y equals, get a fraction, 2 over root 3 root 14, oops, 4, and that should do it. Now I've got it in radian mode. Okay, so let's go pop that into degree mode and try it again. Alright, usually we use degrees with vector questions. So 72.0 degrees.